Hello everyone. So in this video I'll quickly explain what is carbocation. So let us say we have Cr3Cl, where this R group can be hydrogen, alkyl or any aryl group. And we know that out of carbon and chlorine, chlorine is more electronegative. So since chlorine is more electronegative, it will be having delta negative charge and carbon will be having delta positive charge. Now let us say by any means that this bond which is present between carbon and chlorine, if this breaks heterolytically, so then what will happen? Both these electrons will shift on chlorine, which is a more electronegative atom. So if that happens, what we get? So we'll be getting Cr3, where carbon will be having positive charge because carbon has lost this electron, whereas chlorine has gained this electron, so it will be having negative charge. And this carbon which is having positive charge, this is what we mean by carbocation. Fine. So the first point what we can tell here is that the carbocations are formed due to the heterolytic cleavage. So the first point is these are formed due to heterolytic cleavage. Fine. So this is the first point. Now let us see the structure of this carbocation. So you have carbon in the center, which is surrounded by three groups. So that is the first one, second one, third one. And this carbon, it is having a vacant orbital here. So this is the vacant orbital. Fine. So if you see around this carbon, there are three bonds and each bond is having 2 electrons each. So total around this carbon, there are only 6 electrons. Now we know that if the atom, if it is having 8 electrons around it, generally it will be more stable. But in this case, this carbon is having only 6 electrons. So that means this carbon's octet is incomplete. So the second point what I can write, it has incomplete octet. Now if it, let us say, gains 2 electrons, it will be having how many electrons? 8 electrons. So if it has 8 electrons, compared to this, it will be more stable. So since it can accept 2 electrons, this will behave as electrophile. So this will behave as electrophile. That is the second point we have. Now if you see this carbon, around this it is having 3 sigma bonds and 0 lone pairs. Now if it is having 3 sigma and 0 lone pairs, the hybridization of this carbon will be sp2. And if the hybridization is sp2, its geometry will be trigonal planar. So in this case, the geometry is trigonal planar. Now if the geometry is trigonal planar, the bond angle here will be 120 degrees. That is another point. Now last point, if you see all the bonds, they are having 2 electrons each. So all the electrons are paired. So basically this carbocation, this is diamagnetic in nature. Diamagnetic in nature. Fine. So this is a brief explanation about carbocation. So hope you enjoyed it. So until next video, bye bye.